Over 100 million produced, 75 years of unbroken history, from raw iron and carburetors to all-aluminum supercharged monsters. This is the architecture that defined American horsepower. Today, we are morphing through the complete evolution of the legendary small block Chevy. We start in 1955. Engineer Ed Cole was tasked with replacing the aging inline six, and he delivered a masterpiece. The original 265 cubic inch V8 was compact, lightweight, and utilized a simple, brilliant pushrod design. Pushing out 195 horsepower in the Corvette and Bel Air, it changed the automotive landscape overnight. Just 2 years later, in 1957, Chevrolet achieved the holy grail of engineering, 1 horsepower per cubic inch, by boring the block to 283 cubic inches and strapping on this iconic ribbed ramjet mechanical fuel injection system. The Fuelie became a street racing legend. By 1962, the small block grew to 327 cubic inches. To this day, purists consider the 327 the most perfectly balanced Gen 1 engine ever built. With a massive 4-inch bore and a short stroke, it loved to rev, eventually screaming its way to 375 horsepower in the legendary fuel-injected Corvettes. By 1969, the muscle car wars were raging, and the small block grew into its most famous displacement, the 350. Topped with a Rochester 4-barrel carb and that classic round air cleaner, this 5.7-liter workhorse peaked at an incredible 370 horsepower in the LT1, cementing its status in backyards and drag strips across the world. In 1970, Chevy pushed the original block architecture to its absolute physical limit. To reach 400 cubic inches, engineers had to use Siamesed cylinders, removing the cooling passages between the massive 4 and 1/8-inch bores. It wasn't a high rever, but it was a pure torque monster. The late 1970s emissions crisis nearly choked the V8 out of existence. To fight back, Chevy introduced the 1982 Crossfire injection system on the L83 350. It featured 2 Rochester throttle bodies sitting on a cross-ram intake manifold. Sure, the notoriously small intake runners restricted airflow, and mechanics sarcastically nicknamed it the ceasefire, but it was the first fuel-injected Corvette since the 60s. It was a necessary stepping stone that paved the way for the future. To survive the 1980s, the small block had to adapt. Enter the 1985 tuned port injection. This visually striking setup, known as the Aluminum Octopus, used long runners to claw back massive low-end torque. It marked the birth of modern computer-controlled performance. But for the top-tier Corvette ZR1, Chevy wanted to hunt Ferraris. In 1990, they did the unthinkable. They temporarily ditched the pushrods. They hired Lotus to design a 32-valve dual overhead cam masterpiece and had Mercury Marine build it in Oklahoma. Dubbed the LT5, this king of the hill engine made 375 horsepower and proved American engineering could be exotic. By 1992, Chevrolet was ready for a major technological leap. Enter Generation 2, championed by the 300 horsepower LT1. It retained the classic 350 cubic inch displacement, but introduced reverse flow cooling. By routing coolant to the cylinder heads first, engineers could safely raise the compression ratio for more power. Paired with the new front-mounted OptiSpark ignition system, the LT1 finally brought the base Corvette back to the 300 horsepower mark and powered iconic 90s muscle like the Camaro Z28 and Impala SS. After 40 years, it was time for a clean sheet of paper. In 1997, Gen 3 arrived with the legendary LS1. The block and heads were now cast entirely in aluminum, dropping massive weight. It introduced a coil-on-plug ignition system and unmatched airflow. This architecture was so bulletproof and powerful, it ignited the modern LS swap-everything phenomenon. But Chevrolet wasn't done with naturally aspirated power. In 2006, they resurrected a legendary number, the 427. The The 7-liter LS7 powered the C6Z06, packed with titanium connecting rods and a dry sump oiling system. It was essentially a street-legal race engine pushing 505 horsepower. It remains the largest small block ever produced. While the base LS engines continued to evolve through the 2000s, Gen 4 brought something truly terrifying to the table. In 2009, forced induction. This is the LS9. By bolting a massive Eaton supercharger to the top of a forged 6.2-liter block, Chevrolet created a 638 horsepower monster for the C6ZR1. It proved that the small block could go toe-to-toe with million-dollar European exotics, all while keeping its pushrod roots. When Generation 5 arrived, the modern hypercar era officially began. By combining the new direct fuel injection technology with forced induction, Chevrolet released the 2015 LT4, powering the C7Z06. This supercharged 6.2-liter dropped 650 horsepower and enough low-end torque to completely overpower its rear tires. In 2019, they unleashed the LT5 for the C7ZR1. By strapping a massive 2.65-liter supercharger to the top of the block, it pushed out a staggering 755 horsepower. It was the absolute pinnacle and the final send-off for the traditional front-engine Corvette. But when the Corvette finally moved the engine to the middle for the C8 generation, the architecture had to evolve. Enter the 5.5-liter LT6. Codenamed Gemini, this masterpiece ditched the pushrods for dual overhead cams and a flat-plane crankshaft. Screaming to an 8,600 RPM redline, it generates 670 horsepower, officially making it the most powerful naturally aspirated production V8 in world history. But Chevrolet wasn't done with the Gemini architecture. In 2025, they did the unthinkable. They added factory twin turbos to the 5.5-liter, creating the LT7, pushing an earth-shattering 1,064 horsepower for the C8 ZR1. It instantly became the most powerful factory Corvette ever produced. Now paired with the E-Ray electric motors, the ZR1X, the quarter mile comes up in under 9 seconds at a trap speed of over 150 miles per hour. It proved to the world that even in the modern era of electrification, internal combustion still rules the hypercar world. As we look toward 2030 and beyond, rumors of a Gen 6 small block persist. Through advanced titanium and carbon composites, and perhaps a marriage with hybrid assist, the pushrod V8 refuses to die. 100 million engines later, the heartbeat of American performance beats as loud as ever.